Hello, good morning, everyone. Now is our invited keynote speech for Professor Samuel Kortum from Yale University. So it's my honor to introduce Professor Samuel Kortum. He is James Burroughs Moffett Professor of Economics at Yale University, member of American Academy of Arts and Science, and a research associate at MBER. He had previously taught in Chicago University, University of Minnesota, and Boston University, and also was economics in Federal Reserve Board, right? And he was elected as a Fellow of Econometric Society in 2012. So, in the trade field, everyone knows Sam. Don't need me to explain. His contribution to this field, particularly his paper in Econometric 2002. Technology, geography, and trade won received the free trade medal for this paper. And this paper is a major breakthrough for our trade field, which opening up the quantitative trade model. And actually, once Professor Paul Antras commented the contribution of this paper, he said in the trade field in 1990s we don't have much quantitative trade models, but now we see lots of quantitative exercise like macroeconomics did. We couldn't do it without Samuel's econometric paper in 2002. And in addition to Professor Kortum's work in international economics, he also written many papers, famous papers, important papers in economic growth, I/O, and particularly on technology, diffusions and firm dynamics. And Professor Kortum has published many top journals, including AER Econometrica, JPE, and so on. And he was the editor of Journal of Political Economics before, and he was on the economics panel of the National Science Foundation. Today his talk is about firm-to-firm network and trade. I want to see, in classical, actually all-in model, we are talking about trade between countries, and the Krugman's model, we're talking about intra-industry trade. And the Madison model, we start talking about firm-to-country trade. Now it's the year of the firm-to-firm trade. So let's welcome Professor Samuel Kortum, and join me, please. Okay, so it's yours.
Okay, thank you for the introduction, and thank you for being here. So this is very much work with my co-authors, Jonathan Eaton and Francis Cremars, but I didn't let them see these slides, so I haven't put their name on the front here, but they deserve any credit that would be worthwhile. So give you kind of an overview of what I want to talk about today. I want to talk about recent work that has looked at trade more from the point of view of individual firms interacting, and from the buying side, that would mean a firm looking for an intermediate input, and then on the selling side, of course, it's just a firm looking for a customer, but typically we're going to be thinking then about a customer who is another firm, and the firm producing an intermediate. We want to think about this. One can imagine this going on within countries, and we just want to think about it going on within countries and across countries at the same time. Now, one goal of this, and our goal in starting this work, particularly pushed by our co-author Francis Cremars, who's a labor guy, he always wanted us to think about the interaction of trade and individual jobs at firms. And so the idea behind that was that when a firm is purchasing an input, it may be using that input to replace workers in a task that it was doing. Now, that doesn't mean the overall size of the employment of the firm would go down, because perhaps by purchasing this input, the firm expands and it employs more people in other tasks. But in any case, that was sort of an overriding kind of push for us to think about international trade this way, is to really have a very granular look at the role, the connection between trade and employment. But in today's talk, I'm going to emphasize something else, which is kind of the way in which this type of model gives you a richer sense of what we mean by trade frictions. So that's what I want to emphasize today. Now, the evolution of the literature, as I see it, that at least we're building on, and so the way I'm going to tell the story really comes out of work from originally with Bob Lucas, who was talking about a model of technological change or idea flows among people that actually led to a model of economic growth. But it was a model of growth through individual people meeting randomly and exchanging ideas. The idea was that when two people meet, you kind of leave that encounter with each person knowing, with each person leaving the encounter knowing as much as either of them did to begin with. So if one person comes in without knowing very much and the other knows a lot, well, they both leave knowing a lot because they shared their ideas and the ideas were non-rival. But that kind of way of modeling, which is also reflected in the Lucas Moll paper and work by Perla and Tonetti, where it's individual firms connecting and exchanging ideas, that kind of led to a model of firms meeting and exchanging inputs. And that was worked on by this very nice paper that's being revised for econometric by Ezra Oberfield. Now, kind of simultaneously, Thomas Chenet was working on trying to build a model explicitly of international trade built on this kind of individual firms meeting and having a transaction either, well, in fact, either internationally or domestically. And in that kind of world, then the way you think about trade frictions is really more of an information friction or a search friction rather than our typical way of modeling trade frictions as iceberg costs or some physical cost that actually makes the good more expensive. This other way of thinking doesn't really have directly any price implications, but it still is a friction that can inhibit the flows of transactions. Okay, so the EKK stands for Eaton, Kortum, and Kramars, and we kind of built on that idea. And in a way, I would say what we did relative to Thomas and what we're still doing, because our paper is not finished, is to add a little more structure, put a little more meat on the bones of Thomas' approach. So, what are the fundamental features of this approach? Well, in both the Lucas and Oberfield, it comes out very clearly, and that is something that that's part of what we're doing, is there's this kind of fixed point happening in the middle of the model, which is that as you meet the people you meet, there's some distribution of knowledge in the Lucas model or costs in our model. There's a distribution of that, and that's reflected in all the firms that are interacting in the model. And then that's going to affect who you're going to meet as a firm looking for an input. And then that affects your own costs, because if you meet lower cost firms, that lowers your costs. But you're one of the firms in that distribution, and so one has to solve for this distribution that sort of replicates itself. So that's what I mean by the kind of fixed point idea. So that was very clear in Lucas and Oberfield, and we're finding a very similar feature in what we're doing, where we have to solve for a kind of distribution of costs of firms. Okay. But as we've worked with this model, something that has become apparent is that in a model like this, where firms kind of meet randomly, that search friction acts in a way like a fixed cost in a Melitz type model. And so that's sort of intriguing, because it gives us a different foundation for some of the facts that the Melitz model really helped us understand. For example, the role of scale the role of country scale in determining how many firms export to a particular country. And as I said before, it also gives a nice way of thinking about trade frictions. It gets us away, perhaps, from so much reliance on the iceberg assumption. Okay, so I wanted to do a quick peek at the data just so you knew I was talking about something in reality and not just in my head. So I'm going to take some data from the paper by Cremars, our co-author Martin and Mejean, that's about French exporters and their individual customers in different EU countries. But a parallel data set, and in some ways nicer than this one, has been worked on by Andy Bernard, Moxness, and Ultevit Mo, and it concerns Norwegian firms, and it also has the dimension of knowing about the individual buyers, and a nice thing is it covers buyers in any country of the world. Now, what's somewhat reassuring is that some of the facts they've uncovered look a lot like some of the facts we've uncovered. So I feel like in showing you the facts for France, it looks like something that's going to be a bit more general than just something about France, certainly something about Norway as well. So I drew this picture, which got a bit cropped, but I think it gives you just kind of helps understand the dimensions of the data. So we're going to be dealing with France as the exporter, and then buying countries are EU countries. They could be big ones like Germany, or they could be small ones like Lithuania. So the idea is that we're going to see these links from firms in France who export, and then we'll see how many customers they have. So firm 1 there has just 1 customer in Germany. But now take firm 3. It has 3 customers in Germany, and it also has a customer in Lithuania. Now, I kind of drew this with some realism in mind, in that more firms are exporting to Germany. That's a kind of prominent feature of these types of data. And then to more firms selling to Germany than Lithuania. And then notice there's also a situation where 2 French firms could be selling to the same German firm. There's nothing that prevents that from happening, and we see that kind of thing in the data a lot. Now, maybe that's enough said for now. I'm going to come back to these data. I'm going to show you just one thing from the data right now to kind of get you thinking about something tangible. So here I have Lithuania and Germany. I also have Denmark and UK, and I didn't want to make a huge table with all 24 of these EU countries that don't include France, because we actually know more about what's going on outside of France when we're talking about the French exporters. So what you see here is the top row is just giving you the size of the scale of these economies. It's just the total absorption in manufacturing. But what the second row is interesting, it starts to tell you how sort of granular the data is when you cut it this way. The average French firm that's exporting to Lithuania has only 1.5 buyers in Lithuania. And in fact, the median is only 1, and the 75th percentile is just 2. So only 25% of French firms have more than 2 buyers when they're selling in Lithuania. Now, of course, there are more in Germany, an average of 9, but notice that the median is still only 2. But then at the upper end, you're getting to the 99th percentile. I mean, there are 1% of French firms who have, over 100 buyers in Germany. So that's the kind of a cut of the kind of data we want to be having a model that explains or that fits. Now, there's a much bigger literature. Here I'm not including the papers that I've kind of singled out either before or coming up, but it's a growing literature, and I'm sure I've left out important papers, but I just wanted to give you a sense of the amount of work going on in this area. So I wanted to kind of focus in on, I kind of highlighted Thomas' work because I think he really gets some credit for pushing this idea of a kind of network theory of international trade. And particularly, I'm going to be talking about a result in his JPE paper, which is forthcoming, in fact. So in that paper, he wants to explain the gravity equation. Now, a lot of people have talked about explaining the gravity equation, so let me just describe it. It's a way of thinking about how much country N buys from country I. I've included a T subscript for time for a particular reason. I'll come to that later. So in the numerator, we have the product of the GDPs of the purchasing country and the exporting country. And then in the denominator, we have the K and I, the kilometers distance between N and I. And then I have an extra parameter, the alpha T. Now, what Thomas points out, and I fully agree, is that a lot of the early work was kind of emphasizing how are we going to explain this y times y here. Well, that's kind of easy because, you know, if a country's twice as big, it'll probably export twice as much. If it's twice as big, it'll probably import twice as much. So it's sort of obvious that you get the numerator. What's not so obvious is the denominator. And I've written it this way, and Thomas emphasizes this as well. Of course, that's the whole point of his paper, is that the K and I is just naked. There's no coefficient there. It's sort of implicitly an elasticity of 1, and that's what you find in the data. Not exactly, but amazingly, you can look at trade over time, and what's happening is trade is going up. That's why I need the alpha T. Relative to GDP's, trade's growing, but it's not because of the coefficient on distance. It's because of the alpha T changing. So that cries out for a theory, and that was what Thomas was trying to do, is what's the theory of why there should be that K and I there just nakedly with its coefficient of elasticity of 1. OK, so that's the objective. And I'm saying that he's sort of, I mean, I think similar to my work with Jonathan and Francis, where we sort of went into this with a certain goals and sort of find interesting stuff along the way. In fact, his first paper doesn't talk about this, but then he realized, and for a long time he had been kind of seeking such a model, but once he had sort of developed this model of trade in a network, he kind of realized it might actually help explain that coefficient of 1 on the kilometers. OK, so the basic, I find it's kind of easier to take some other person's paper and distill it rather than your own. When it's your own, you can't help but want to include too much stuff, which you'll see I did later. But for Thomas, I was happy to strip things down. So in his model, there are these firms that are born, and they're kind of collecting customers over time. And these customers are located in a kind of geographical space. And so some of the customers are going to be far from the firm, some are close. But then it gets new customers through its existing customers by getting connections through its current set of customers for new customers. And so that means that as the firm ages, it grows because it accumulates more and more customers, and they kind of get spread out more and more across space. So it's very natural to get two kind of results out of such a model. This sort of geometric growth very naturally gives you a Pareto distribution for the size distribution. So we'll keep doing that. So that's what I've represented here. I've done it here in terms of the measure of firms. There's a certain reason for doing it that way, but it's this coefficient of size to a power, which is representing the Pareto-ness of this. And then the other result you get very naturally out of this model, and his result is much more general. I've taken a very special case that just makes it easy to talk about, but you would typically get your trade spreading out across space as you get bigger. And you get bigger with age in this model. But that's what I'm representing here, is that the distance in kilometers of a firm of size X, you could think of it, the distance of its customers as kind of being drawn from an exponential distribution with a parameter that depends on the size of the firm. And so as the firm gets bigger, it gets more spread out, that exponential distribution. So in fact, Thomas' result doesn't require an exponential distribution, but I like to have something that works out nice and simple. So that's what I've done. Now, you want to figure out volume of trade at distance k, at kilometers k, all you have to do is integrate that distribution of the distance of your trade for a firm of size x, integrate that over the size distribution of firms, and lo and behold, you get this great result, d to the minus lambda. Now, if you have Zipf's law, lambda equals 1, boom, you have d to the minus 1, which is exactly what, or sorry, k. I did have d in my slides, and then I realized when you do an integral, it looks kind of funny to say dd. So I changed it to kilometers. So that's why I said that wrong. Oh, and that's why I wrote that wrong. I forgot to change that. That's k to the minus lambda. So if lambda equals 1, as with a Zipf's distribution of firm size, then you get a k inverse, and you get exactly what we're seeing in the gravity model. So that's Thomas' explanation, kind of coming out of this style of modeling trade, which I think is quite nice. Now let's contrast that to a typical model. I mean, I could take my own model with Jonathan. We would not get that coefficient except as some sort of coincidence, because it involves the product of the trade elasticity and the elasticity of iceberg costs with respect to distance, and why the heck should that product equal 1? Whereas here's a direct theory giving you 1. Okay, so that's the idea of that, is to kind of show this style has a lot of potential. This style of modeling trade, I think, has a lot of potential. So now I'm going to turn to my work with Jonathan and Francis. I'm going to show you some data, kind of go back to that data that I just showed you a little bit of. And what I want to take from that is, just like Thomas had this great target of trying to explain that coefficient in the gravity model on kilometers, well, it's nice to look at this data and look at certain facts that just kind of jump out, and those should be the target of the theory. So that's what I want, when we're looking at the data, that's what I want to be doing. Then I'm going to give you a brief overview of our model, probably more detail than I should have included, kind of talk about the way in which it generates a gravity equation, and then talk about how we can predict some things that aren't the typical prediction of a trade model, which is going to be the measure of producers in each country. That's going to be endogenous. The measure, the exporters in each country to each destination, and the number of relationships. And I put that in italics because I'm going to tell you what I mean by that in a second. Okay, so let me start with some identities, and that'll give me a chance to define what I mean by relationships. But one identity is obviously that you can just take the trade between a country, say France, how much it exports to country N, and you could break that into the market size of country N, and then French market share of that market, and that's the pi NF. So the pi NF, that notation is going to show up in several places in the rest of this talk. We can also break up, we can also do another decomposition, which is to take the number of French exporters to a country and the mean number of customers such a French exporter would have, and that's the number where we had 1.5 for Lithuania and 9.6 for Germany. That's the B bar. The product of that is what I'm calling relationships between French firms, French exporters, and buyers in the destination N. So that's what I mean by relationships, just that product. So if you went back to my picture here, you can see the relationships of French firms with German firms is going to equal the, it'll be the 1 plus 2 plus 3. So we have 6 relationships between French firms and German buyers, and only 1 relationship between French firms and Lithuanian buyers. Okay. So what does that look like? Well, let's use that decomposition to just project some of these numbers onto aggregates such as the market size and the market share. We found this useful in earlier work, and one thing we found was that the number of French exporters to a destination N, rose significantly with market size and with French market share. Now, in fact, this coefficient here, the fact that wasn't 0, led us to want, in our earlier work, a model that has some sort of scale effect in it, which was in fact missing in our earlier work with Andy Bernard and Brad Jensen, which predicted a 0 coefficient here and a coefficient of 1 here. Okay, now interestingly, notice that the coefficient on market share is much less than 1, but now you go down to the relationships, these coefficients are much bigger. The coefficient of 0.83 on market size, the coefficient almost exactly 1 on market share. So as French market share goes up, doubles, number of relationships pretty much doubles. And that's going to be something that's going to be a target for our theory to try and explain that. Now, the last thing is really redundant because notice the coefficients are just the difference between the second regression and the first regression. But it's sort of intuitive to think about that the average number of buyers per French firm in a market rises with market size. Well, we kind of saw that as we looked across Lithuania versus Germany. And then it also rises with French market share. And interestingly, this thing is a little bit of a clue about the role of bilateral search frictions, because in a world without such frictions, that coefficient in our theory would equal 0. So that's a little bit of a sort of evidence that'll be coming up for such an effect. Okay, so let me step back for a second. Take that second regression. Notice with the coefficient of 1 on French market share, we can just bring that to the left-hand side, redefine the variable to be French relationships with market N divided by French market share and the log of that. And then we can plot it as a one-dimensional figure against market size. And the reason that's nice is just it's just a very nice visualization of the data. And I think it's just striking how, how that lies on such a nice line in a log-log scale with Germany at the top and Malta at the bottom. Okay, so we're going to want to be able to explain something like that. Now, the next picture is a little hard to understand, so let me talk about it for a moment first. This next picture is going to capture a kind of selection effect that's in the model, which is the idea that if you take the firms that have been able to make it into a country that very few French firms make it into, those should be sort of the stellar firms. Now, how are we going to learn about that? Well, we're going to look at that through the lens of Germany. We're going to take Germany as sort of the common country, and we're going to look at how many buyers these firms have in Germany, and we're going to look how that varies as we take firms which not only are exporting to Germany, but are exporting to some other country. And if that other country is a small one that few French firms export to, that should create a really strong selection effect, and we should see more buyers in Germany. And that's what we do see. And this is another target in the sense that it's just very striking how this comes out so linear on a log scale. So what it's saying is if you take the French firms that are, there's Lithuania. If you take the French firms that are selling to Germany and Lithuania, they have a lot more, they have 30 customers, where if you just take any old French firm selling to Germany, that only has the 9.6 customers. So as you apply a stronger and stronger selection, through how these firms do in other markets, you see that reflected in how they do in a common market such as Germany. So that's another kind of target. So now I've kind of established a couple of targets sort of in the nature of Thomas' target on the gravity model coefficient of distance. Okay, now, what do I have about 15 minutes? Okay, so I'm going to have to go very quickly through the theory, which is probably a good thing. So this is we're going to have a model of many countries, And the key thing here is that they're separated not only by iceberg costs, as we would typically measure it, the DNI being sort of how many units you have to ship from country I to get one to arrive in country N. That's a physical cost. But then there are also these search frictions that are bilateral, and I put them in red because they're kind of the new thing and the thing I want to sort of emphasize in this talk. Okay, now, with a similar notation that I used in deriving Thomas' result, I have here the kind of starting point of the theory, which is that firms do differ in efficiency right from the get-go. Now, in some ways, Thomas' paper goes deeper in the sense that he starts with sort of nothing, and then the firms just get these firms age, and you generate a size distribution from that aging process that brings you new customers. Here, we're actually starting with a kind of distribution of efficiency levels across firms that has this sort of Pareto shape. That's similar to what we did in our earlier work where we were using the Melitz model. In fact, we're taking this exactly from that earlier theory. Now, each firm here, what's new here is that the production technology is different. You use labor, but you always have this, you actually have to carry out a bunch of tasks as a firm. And for each task, you can either use labor or you could decide to use an input that you buy from one of the other firms. And that's what generates the network, is that you might want to buy from other firms to replace your labor with an input purchased from that firm. And then your own output may be used by another firm to replace its employment in a particular task. Now, it's not wiping out all the employment. It's in one task. The firm has capital K of these tasks. But a firm can become sort of more hollowed out using lots of intermediates, lots of inputs purchased from other firms, or it can remain very much high value added firm, almost doing everything from scratch using its own labor. Okay. Now here's kind of a picture of what's going on in this firm. In this model, I'm sorry. Each firm here has two tasks described by these two boxes that represent the firm. Arrows going out mean a product that the firm produces and sells to somebody else. Arrows coming in are an input that it's purchasing. So the firm number one here, and they're ordered here by lower cost. So lower cost firms have an advantage in this model. Why? Because there are going to be two things. One, very naturally, when they provide an input, it's going to tend to be the low-cost input, and the buyer is going to want to buy from them because it's low cost. Whereas a high-cost firm, it meets a buyer. The buyer may kind of snub its nose at that firm because it'll say, well, I already know about some other supplier who can do it cheaper than that. Okay, so the low-cost firm has an advantage in getting customers, and so I show this firm having two customers, one that's not shown in the picture and one that's firm number two. And it's providing an input for firm number two to perform task two. Now, firm number one is getting one task performed by firm number three, and then the other task it's doing with its own labor. Firm number one has two buyers and one supplier. Firm number two has one buyer who's off the charts and two suppliers because it's getting one supplier from outside the picture and it's getting one supplier for task two, which is firm number one. And then finally, it's possible for a firm to have no suppliers, but it's got to have a customer because if it doesn't have a buyer, it's not going to exist in our world. So every firm has to have a buyer. So buyers, the number of buyers can't be less than one. There's no real upper bound. It can go to countable infinity. And then in terms of number of suppliers, that maxes out at k because there are only k tasks to be done, and you can at most have one supplier for each task. So that gives you a kind of structure of the model. Now, to see a little bit of the math of it, well, underlying the model is you can think of it this way, that there's a matching function underlying the model, which is the matches between buyers and the firms whose cost is less than C. And because there's cost heterogeneity, we always have to talk about the matching between firms, between suppliers of different costs. So that's what you're seeing there. Let's see. I have to be a little careful about what I do, because I have 10 minutes. So let me just do a couple things carefully here and then kind of skip over a bunch of stuff. So I like this result, so I'm going to emphasize it. So and then buyer is going to, okay, so there's this matching function. That kind of talks about the aggregate matches between buyers and sellers. These are all the buyers, and then here are the sellers over here. The sellers described via this distribution because it depends on their costs. Now let's go over to a buyer. Now a buyer is only going to see a certain number of suppliers, and that's the friction, the fact it doesn't see everybody. And that's orchestrated by this lambda here. So it's going to see a number of buyers that's distributed Poisson with this parameter. It's going to see that many buyers whose cost is less than C. Now, if it sees that many buyers, then you can say, what's the probability that it's going to see a buyer with a cost less than C? Well, that's going to be 1 minus the probability it doesn't see any buyers, which is just e to the minus rho. So right off the bat, we get a nice result about the distribution of prices faced by a buyer in terms of the prices of the suppliers. And that's kind of what gets a model up and running. So now, having said that, I'm going to skip over some stuff. You kind of see there's a structure there. I'm going to jump to here because this is, remember I was talking about Lucas and Overfield. There's kind of a fixed point at the middle of those models in a distribution. And here is, for us, what that fixed point is. It's giving us the measure of firms from I that can supply country N at a cost less than C. And what does that depend on? Well, that depends on C, of course. And the reason the model works is because we retain this C to the theta shape, because that's sort of the magic of the model, is that you stay within this functional form. But what's going on? Well, you see the T, which was we had from the get-go with our assumption about efficiency. And then we have the xi. That's the new part. That's the endogenous part. That's the part that grows if countries, if firms are more connected in the economy. And you see that through this. This is the equation for xi. And it's an equation with xi on both sides, but you can show that the xi is going to be increasing in all these connections between firms in different countries. And in fact, it's connections between individual firms, but one can write it in this aggregate form. And that's sort of the role of these search frictions in, if they're strong enough, they raise the cost of firms. And as they go down, in this case, they go up, there's more knowledge flows among firms. Firms know more about potential suppliers, and costs go down. And that's what's captured on this slide. OK. So macro implications, well, here are the things that are really going to be helpful for us in turning this model into something we can use empirically, because it generates a gravity equation. And in fact, it's not such a weird one. There are two things about it that are different than the typical one. And remember, pi and I is a fraction of country N's expenditure that's devoted to goods purchased from country I. First of all, the trade friction term is the product of the information friction and the iceberg cost friction. Second of all is the xi. Okay, so that otherwise it's a very standard kind of model. And then the other part of this theory is it gives you a theory of labor share. It gives you a theory of labor share relative to the material share. So not labor share relative to capital share, but labor share relative to materials. Because remember, there's this story about being hollowed out. If you are a firm who does all its tasks by buying goods from other firms, well, then you have very little value added, very small labor share. And this is giving you what the model implies for that labor share. And the labor share is declining in the wage and increasing in the cost of intermediates. Okay, so I only have 5 minutes, so I need to skip ahead a little to these firm level results. So now let's kind of, at this point, we kind of have the key parts of the model that one would have to think about for computing general equilibrium and so on. And I skipped over that because that's not really a part of what I want to do today. But what I want to spend a little bit of time on is the implications at the firm level, the things that we can relate to that data on relationships on exports and buyers per firm and so on. Okay, so we have that matching function. Now we're going to kind of turn it around and look at it from the perspective of the suppliers finding buyers. So then we see our bilateral trade, our bilateral knowledge friction here. We see the measure of buyers. And we're talking about a parameter that's going to be the Poisson parameter for the number of buyers that a firm delivering at cost C is going to have in some market N if it comes from country I. So it's got this lambda Ni. It's got all these customers it can run into. They're either firms, that's M, or households directly, that's L. And then if it runs into these buyers, that firm's only going to make a sale if it's the low-cost one that met those firms. And this 1 minus G is the probability that that firm with cost C is going to be the low-cost supplier. And so that's why we have to multiply by 1 minus G there. OK. And then this is just to remind you, we already talked about this guy. This was kind of at the center of our model, the measure of firms from country I that can deliver to country N at a cost less than C. So now, when we're trying to get these firm-level objects, we're basically just integrating different functions of this against this. Because we got to integrate out the C, but this gives us a way to integrate out the C. So for example, if we want to know the endogenous number of producers in country N, we just calculate the probability that a firm in country I, the probability that a firm in country I will have a customer anywhere, or actually the Poisson parameter for that. And then we just say, well, let's integrate up all the firms in I who have at least one customer in the world. They're going to be firms that exist, and we just integrate that up over the distribution of firm costs in country I. So that gives us the measure of active suppliers in country I. We do something very similar with exporters. So we take, what's the probability that a firm from country I will have no customers in country N? Well, 1 minus that means it has at least one customer there. Integrate that over the cost distribution, and we get our measure of firms from country I that export to country N. Now, I want to point to something interesting here, which is that notice there's no lambda. The lambda Ni is buried up in this nonlinear function. Now, in fact, there's a dni to the minus theta sitting right in there, and that could be pulled right out to the outside. But there's no lambda Ni like that. The lambda Ni only enters through that. So even though in the gravity equation, it's lambda Ni times dni to the minus theta that's the trade friction, and you might have wondered, how could we ever split those up? Well, in the equation for exporters, it's getting split up. The lambda Ni is only going up there, the dni is going down there. So you get a kind of differentiation there that can help identify the role of these information frictions relative to iceberg costs. And now finally, let's go to the nice equation, which is the one for relationships. So that was the one that looked pretty in terms of the scatter plot. It also looks pretty in terms of the math. So this is the number of relationships between country I and country N. So there, all I have to do is integrate the eta itself, because you just want the number of relationships. And the eta gives you the number of the Poisson parameter for the number of buyers. You just integrate that up over the cost distribution. And doing that, I mean, I guess because it's nice and linear like this, you can solve it. And you can do a little work, and that turns out to just be the product of the trade share of country I and country N times the measure of active producers in country N times the measure of tasks that have to be performed times the fraction of those tasks that get outsourced. And those all put together give you the relationships. Now, what's nice about that? Well, we saw there's a coefficient of 1 in logs when you regress R and I on the trade share, and that's coming right out of the theory. And then if we think of the MN as kind of a proxy for market size, well, then we've got our equation that we saw in the data that I did the scatter plot of. And then secondly, I want to point out, well, because that's pi and I there, for relationships, it is the product of these two showing up together. So relationships versus exporters are quite different things. Why is that? What's the nonlinearity in the number of exporters? It's because you're an exporter as long as you have at least one customer in that country, whereas relationships can just keep going up as you penetrate farther into that country. But once you've got one customer there, you're already an exporter, and you can't become more than you're just an exporter. You can't become two exporters just because you have more customers in that market. Okay. So then you can work out the size, you can work out the distribution of number of customers as well, and that's what we're doing here. Okay, so now let me just say that, because I have, what, 2 minutes, 1 minute? Okay, so that's a good time to jump to results. And this is very preliminary work, so that's probably, I'm just kind of going through an estimation strategy here. But here are the preliminary results so far, with basically not even having, optimized over all the parameters yet. These are the results for buyers per French exporter, and I just showed it for the same countries that I showed you that original table for. And notice here, we really can nail this kind of statistic. We're getting the average just about right. This is actually the data that's 1.5, and that's 9.6, really close. This is almost identical. The median, you just got 1 or 2 customers. At the upper end, you have a pretty large number. In Germany, still pretty small in Lithuania. I just have like 2 slides, so I think I won't be too far over. Okay, what about the simulated versions of the regressions we looked at? Now, all I've done here is we've simulated these left-hand side variables. I've replaced market size with MN. And I'm just using the actual data on French market share because the estimation procedure conditions on that anyway. And you can see that these equations are looking very similar to the data, except that coefficient's a bit too big. But that one's dead on 1. These are quite a bit less than 1, as in the data. And then finally, how do we do with that sort of difficult to describe plot that involves customers in Germany? Well, here I've converted that into regression. This is the data. So this just corresponds to the regression of the figure that I showed you. Just that slope that was a slope of minus 0.38 we were looking at before. In my simulated version of this kind of funny statistic, we're not right on. We're getting a minus 0.7, but we're getting the same flavor. So I feel this is pretty, we can be pretty optimistic about a model that has a bit more structure than Thomas, has a different agenda, but I think is very complementary to that work of kind of pushing this idea of thinking about trade as a network. And I'm hoping that by the end of the day, we'll get some pretty good estimates of, here's how much of the trade friction should be attributed to sort of traditional iceberg costs. Here's how much we can think of as information frictions. It might help us not feel so embarrassed when we have to report a model where the iceberg costs are something like 3, and somebody says, well, how could the cost go up by a factor of 3 when you're shipping from, China to the United States? That's just not, that's not believable. So I think we have hope there. Okay, I'm done.